Universitas Pembangunan Nasional Veteran Jawa Timur, also known as UPN Veteran Jawa Timur, is a public university in Indonesia, founded on the 5th of July 1995 by the veterans. Located at Jalan Rungkut Madya, Gunung Anyar, Surabaya, at around 12 kilometers from the city center. In line with the goal of the veterans, Universitas Pembangunan Nasional Veteran Jawa Timur delivers the best education to take part in developing the quality of human resources, especially in higher education. Welcome to the campus of State Defense. In general, the education of State Defense at Universitas Pembangunan Nasional Veteran Jawa Timur is delivered continuously to the students ever since they are enrolled until they graduate. Materials are delivered in various ways, starting by introducing campus life to the freshmen, giving character building lecture based on the 5 principles of the state defense outbound, state defense-based community service, and other supporting activities as facilitated at the student activity units. A few to mention: students with military training unit, nature club, scout unit, traditional martial arts unit, traditional dance unit, and sports unit. UPN Veteran Jawa Timur has transformed into several statuses, from public university under the Ministry of National Defense into a private university. On the 6th of October 2014, based on the Presidential Decree number 122 year 2014, UPN Veteran Jawa Timur officially transformed into a public university, in accordance with its mission to become an outstanding university with the character of state defense. In 2016, UPN Veteran Jawa Timur was granted accreditation A for higher education institution. In 2018, UPN Veteran Jawa Timur was able to obtain the status of public service agency for its financial management. As in 2019, UPN Veteran Jawa Timur was able to put its name into top 40 rank as the best universities in Indonesia, nominated by the Ministry of Research, Technology, and Higher Education. UPN Veteran Jawa Timur has 7 faculties, consisting Faculty of Economics and Business, Faculty of Agriculture, Faculty of Engineering, Faculty of Social and Political Science, Faculty of Law, Faculty of Architecture and Design, and Faculty of Computer Science. There are 7 fields that become priority targets in the arrangement of devices and institutional strengthening towards professionalism based on research and global competitiveness for university development. Field of education and teaching, field of research and development to the society, field of organization, field of finance, field of human resources, field of facility and infrastructure, and field of cooperation.
Semoga ke depan UPN Veteran Jawa Timur semakin meneguhkan sebagai perguruan tinggi negeri yang mempunyai daya saing tinggi di bidang tridharma perguruan tinggi, tidak saja di tingkat nasional tapi juga di internasional.
Bangunlah seluruh bangsa Indonesia, hadapi tantangan dan cobaan, raihlah cita-cita yang mulia, Indonesia makmur dan sentosa. Walau berbagai suku dan agama, ragam
Indonesia is the most beautiful land in the universe. The land where we were born, the nation where we grew up. So many colors that live together in peace. With a million timeless treasures. With an abundance of natural wealth. Indonesia is not just wonderful. Indonesia is a wonderland.
Kota baru gunungnya bermegah, bermegah, bermanapun di Salangkarang, bermanapun di Salangkarang. Katamu lawanlah adinda, adinda iman tidak darah sama layang, iman tidak darah sama layang. Sayang, sayang, si patokaan makai go gorokan sayang. Sayang, sayang, si patokaan makai go gorokan sayang. Sajojo, yung madam ko bisa papare sa muna keke, sa muna keke. Soleram, soleram, soleram, anak yang manis, janganlah dicium, sayang kalau dicium, merah pipinya. Kampungan jauh di Mato, Kunwangsan sebaku liliang, takkan aja kawan-kawanan lamu, sangke basuh yang suria.
Indonesia dengan ini menyatakan kemerdekaan Indonesia. hal-hal yang mengenai pemindahan kekuasaan dan lain-lain diselenggarakan dengan cara saksama dan dalam tempo yang sesingkat-singkatnya. Jakarta, 17 Agustus 1945, atas nama bangsa Indonesia, Soekarno, Hatta.
Universitas Pembangunan Nasional Veteran Jawa Timur, also known as UPN Veteran Jawa Timur, is a public university in Indonesia, founded on the 5th of July 1995 by the veterans. Located at Jalan Rungkut Madya, Gunung Anyar, Surabaya, at around 12 kilometers from the city center. In line with the goal of the veterans, Universitas Pembangunan Nasional Veteran Jawa Timur delivers the best education to take part in developing the quality of human resources, especially in higher education. Welcome to the campus of State Defense. In general, the education of State Defense at Universitas Pembangunan Nasional Veteran Jawa Timur is delivered continuously to the students ever since they are enrolled until they graduate. Materials are delivered in various ways, starting by introducing campus life to the freshmen, giving character building lecture based on the 5 principles of the state defense outbound, state defense-based community service, and other supporting activities as facilitated at the student activity units. A few to mention: students with military training unit, nature club, scout unit, traditional martial arts unit, traditional dance unit, and sports unit. UPN Veteran Jawa Timur has transformed into several statuses, from public university under the Ministry of National Defense into a private university. On the 6th of October 2014, based on the Presidential Decree number 122 year 2014, UPN Veteran Jawa Timur officially transformed into a public university, in accordance with its mission to become an outstanding university with the character of state defense. In 2016, UPN Veteran Jawa Timur was granted accreditation A for higher education institution. In 2018, UPN Veteran Jawa Timur was able to obtain the status of public service agency for its financial management. As in 2019, UPN Veteran Jawa Timur was able to put its name into top 40 rank as the best universities in Indonesia, nominated by the Ministry of Research, Technology, and Higher Education. UPN Veteran Jawa Timur has 7 faculties, consisting Faculty of Economics and Business, Faculty of Agriculture, Faculty of Engineering, Faculty of Social and Political Science, Faculty of Law, Faculty of Architecture and Design, and Faculty of Computer Science. There are 7 fields that become priority targets in the arrangement of devices and institutional strengthening towards professionalism based on research and global competitiveness for university development. Field of education and teaching, field of research and development to the society, field of organization, field of finance, field of human resources, field of facility and infrastructure, and field of cooperation.
Semoga ke depan UPN Veteran Jawa Timur semakin meneguhkan sebagai perguruan tinggi negeri yang mempunyai daya saing tinggi di bidang tridharma perguruan tinggi, tidak saja di tingkat nasional tapi juga di internasional.
Indonesia makmur dan sentosa. Excellencies, distinguished guest participants, ladies and gentlemen,
Assalamualaikum warahmatullahi wabarakatuh.
May peace be upon us. Good afternoon, and we're delighted to welcome you to the International Guest Lecture, Current Research in Energy Storage and Collaboration Opportunity with Cukurova University of Turkey. Before we begin, let us introduce ourselves as the Master of Ceremonies in today's agenda. I'm Tiara Safianggraini.
And I'm Arya Wiratama, will be escorting you for the next hours. To the Honorable, the Dean of Faculty of Engineering UPN Veteran Jawa Timur, Dr. Jariah, the General Chair of International Guest Lecture, Current Research in Energy Storage and Collaboration Opportunity, Mr. Erwan Saputra, Ph.D. Our moderator, Dr. Aini Fauziyah, Professor Halime Omur Paksoy from Cukurova University, Turkey, as today's keynote speaker, and also participant of today's international guest lecture.
This international guest lecture to bring together academia, researchers, business entrepreneurs, practitioners, and policymakers who are responsible for delivering sustainable and eco-friendly solutions through leveraging advanced information about engineering and technology for competitive advantage and cost savings in modern industrial sector as well as public and business sector.
This international guest lecture provides a great opportunity for prospective participants to share their recent theoretical knowledge, research findings, and experiences in dealing with sustainable information. As such, this international guest lecture will feature presentation by international speakers which are cutting-edge session topics.
Before we proceeding to the main event, let's sing the national anthem Indonesia Raya together, and will be followed by a profile video of Universitas Pembangunan Nasional Jawa Timur.
Universitas Pembangunan Nasional Veteran Jawa Timur, also known as UPN Veteran Jawa Timur, is a public university in Indonesia, founded on the 5th of July 1995 by the veterans. Located at Jalan Rungkut Madya, Gunung Anyar, Surabaya, at around 12 kilometers from the city center. In line with the goal of the veterans, Universitas Pembangunan Nasional Veteran Jawa Timur delivers the best education to take part in developing the quality of human resources, especially in higher education. Welcome to the campus of State Defense. In general, the education of State Defense at Universitas Pembangunan Nasional Veteran Jawa Timur is delivered continuously to the students ever since they are enrolled until they graduate. Materials are delivered in various ways, starting by introducing campus life to the freshmen, giving character building lecture based on the 5 principles of the state defense outbound, state defense based community service, and other supporting activities as facilitated at the student activity units. A few to mention: students with military training unit, nature club, scout unit, traditional martial arts unit, traditional dance unit, and sports unit. UPN Veteran Jawa Timur has transformed into several statuses, from public university under the Ministry of National Defense into a private university. On the 6th of October 2014, based on the Presidential Decree number 122 year 2014, UPN Veteran Jawa Timur officially transformed into a public university, in accordance with its mission to become an outstanding university with the character of state defense. In 2016, UPN Veteran Jawa Timur was granted accreditation A for higher education institution. In 2018, UPN Veteran Jawa Timur was able to obtain the status of public service agency for its financial management. As in 2019, UPN Veteran Jawa Timur was able to put its name into top 40 rank as the best universities in Indonesia, nominated by the Ministry of Research, Technology, and Higher Education. UPN Veteran Jawa Timur has 7 faculties, consisting Faculty of Economics and Business, Faculty of Agriculture, Faculty of Engineering, Faculty of Social and Political Science, Faculty of Law, Faculty of Architecture and Design, and Faculty of Computer Science. There are 7 fields that become priority targets in the arrangement of devices and institutional strengthening towards professionalism based on research and global competitiveness for university development. Field of education and teaching, field of research and development to the society, field of organization, field of finance, field of human resources, field of facility and infrastructure, and field of cooperation.
Semoga ke depan UPN Veteran Jawa Timur semakin meneguhkan sebagai perguruan tinggi negeri yang mempunyai daya saing tinggi di bidang tridharma perguruan tinggi, tidak saja di tingkat nasional tapi juga di internasional.
Excellencies, participants, ladies and gentlemen. We are now going to listen to the report speech delivered by the General Chair of International Guest Lecture, Current Research in Energy Storage and Collaboration Opportunity with Cukurova University, Turkey. Please welcome Mr. Erwan Saputro, Ph.D.
The Honorable Dean of Engineering Faculty, Dr. Jawa, the distinguished speaker, Professor Halime Paksoy, lecturer and staff of engineering faculty, also the distinguished guests, fellow students, ladies and gentlemen. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, praise to God. Today, Monday, 11 October 2021, we are conducting the second international guest lecture as a part of visiting professor program. Ladies and gentlemen, as coordinator of this event, please allow me to inform you a brief review about this program. The visiting professor is annually program from engineering faculty, UPN Veteran Jawa Timur, which include international guest lecture, international workshop, and research collaboration. However, due to the pandemic, some of them canceled and some of the program has been conducted through online. This guest lecture has an attractive topic, which is the current research in energy storage, especially thermal energy storage, and followed by the discussion about the opportunity of collaboration between Cukurova University Turkey and UPN Veteran Jawa Timur. The total registered participant is around 176 participants, which mostly from engineering faculty. A part of Zoom, we provide YouTube streaming as well. So if you cannot, if your friend can enter the Zoom, please direct them to go to our YouTube channel. Ladies and gentlemen, I can see a big potential from this lecture. I hope that through this event, we all can take the benefits and prepare for the collaboration. I don't want to take too much time, so I will hand it over to our Master of Ceremony. Good luck for everyone. Stay safe and stay healthy. Thank you.
Thank you, Mr. Erwan Adi Saputro, Ph.D. for the report speech. And ladies and gentlemen, we're now going to listen to the opening speech delivered by the Dean of Faculty of Engineering, Faculty Event Veteran Jawa Timur. Please welcome Dr. Jaria.
Assalamualaikum warahmatullahi wabarakatuh. Honorable guest, Professor Halime, as a speaker of international guest lecture from Department Chemistry, Cukurova University. All leaders of Engineering Faculty UPN Veteran S Java, distinguished guests, ladies and gentlemen, Alhamdulillahirabbil alamin. We pray to Allah Subhanahu wa Ta'ala to the abundance of grace and gift we are allowed to present in good health. Also, I would like to express my appreciation to Mr. Erwan and team. We generously help us arrange this event. Ladies and gentlemen, it is my great pleasure to be a part of the opening ceremony of the International Guest Lecture Visiting Professor organizing by the Engineering Faculty of UPN Veteran S Java. This guest lecture attended for lecture and academic staff and all students of University Pembangunan Nasional Veteran S Java. Ladies and gentlemen, today's guest lecture has a theme recent research in energy storage and collaboration between UPN Veteran S Java and Cukurova University Turkey. Realizing the importance of an alternative in renewable energy today, this theme is certainly very interesting because in this area, countries in Asia are competing to produce various energy transportation innovation through energy storage, such as fishing material, utilization for solar panels, and their utilization in the power generation. Due to climate change, green energy and green power have become one of the most important things in development around the world. And this is a challenge for UPN veteran as Java to solving problem in the energy sector in this future. Ladies and gentlemen, in improving the relationship and collaboration between UPN veteran as Java and Cukurova University, I hope that we can find opportunities that we can develop to increase cooperation between UPN veteran as Java and Cukurova University. I hope representative from faculty and critics this opportunity. Finally, with blessing for God, I open this international guest lecture, and I hope that this guest lecture will be benefit to us and we enrich our love and literature. This enough for me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Jaria, for the welcoming speech. And now, we will hold a photo session. To keynote speakers, the Dean, Moderator, as well as participants are welcome to take position for photo session. Please kindly open your camera. And I will count 1 to 3. One, two, three. Again. 1, 2, 3. Thank you.
Ladies and gentlemen, today's international guest lecture will be moderated by Dr. Aini Fauziyah about the current research in energy storage and opportunity of academic and research collaboration, followed with a Q&A as well as discussion session. As for the next agenda, please welcome Dr. Aini Fauziyah as our moderator.
Okay, thank you, MC. Good afternoon, everybody. How are you today? I hope you well today. So we can meet together here in this international guest lecture from Cukurova University, Turkey. Okay, first of all, let me introduce myself. My name is Aini Fauziyah. I am from Engineering Faculty, UPN Veteran.
Okay, I think there's a connection problem with our moderator. Please kindly wait for a second.
Okay, can you hear me? No. Okay, I'm so sorry. Can you hear me? Hello?
Yes.
Everybody? Okay,
Yes,
thank
you
you.
can.
I'm so sorry because of the mistakes. Maybe my connection is not good, so I'm so sorry. Okay, thank you, MC, and good afternoon, everybody. I hope you well, so we can meet together in this good opportunity in international guest lecture from Engineering Faculty Universitas Pembangunan Nasional Veteran Jawa Timur. Okay. First of all, let me introduce myself. My name is Aini Fauziyah. from Universitas Pembangunan Nasional Veteran Jawa Timur. Okay, in this meeting, we have honorable speaker, Professor Halime Omur Paksoy. How are you, Professor? Hello.
Hello.
Professor.
I'm
Okay.
fine. I hope you're fine too. Yes.
Okay, thank you, Professor, for joining this meeting. Okay. Thank you. In this meeting, we have interesting topic because we know this is about energy storage. That's right?
Yes.
Okay, thank you. We know that Indonesia have many sources about the energy, like in the sea and then the wind and other sources, and we have to develop this energy and these sources. So by this meeting, we hope that this can be a solution for us to develop the energy in Indonesia, because sometimes if we would like to develop the energy, we meet some obstacle or maybe some challenges about the research or maybe some characterization on other. Maybe you can share with us today. Okay, Professor, before we continue to the presentation, I would like to inform about the rule of this meeting today in this session. First is the presentation from Professor Halime Paksoy, and then continued by the collaboration opportunity between the Cukurova University and UPN Veteran Jawa Timur, and then followed by question and answer. So maybe all of the participants, if have any question, you can write your question in the chat box, or maybe you can ask directly to Professor Halime Paksoy. Okay, Professor, let me share the slide about your CV. Okay. Have you saw my slide?
Yes.
Okay. This is Professor Halime Omur Paksoy. She have a lot of publication and some experience about the energy storage. For the education information, she has finished the doctorate degree from Cukurova University, and then the postgraduate from Cukurova University, and undergraduate from Boğaziçi University from Turkey. And then if you look at the research area, this is about the chemical engineering and technology, and then chemical technologies, chemistry, physical chemistry, nanocomposites, thermodynamic, natural science, engineering and technology. And the H index from Web of Science is 23. Wow, this is very amazing. So maybe we can learn more from Professor Halime. And then the publication is very, is not enough, okay? This is the publication, some comparison of photo electrochemical activities and other, and then CO2 mitigation with thermal energy storage and other publication. Okay, let we welcome Professor Halime Paksoy. Are you ready, Professor?
Yes, I am.
Okay, thank you, Professor. Please, the floor is yours.
Can I share my screen?
Yeah. You can share your slide and try to deliver to us.
Okay, can you see my screen now? Yes, okay, I put it in the presentation mode. Good morning, dear Dean, dear professors, organizers, students, and everybody who is with us, ladies and gentlemen. It's a great pleasure for me to be a presenter for your program to UPN Veteran. As Dr. Fauziyah made a very nice introduction about me and the importance of what we're doing. We're doing research that is very important for the sustainable future of the world, because we are trying to stop climate change by using more renewable energies. And the way to do that is to store renewable energy when it's not available. Storing is both thermally and electrically, but our focus today would be thermal energy storage. My group is called QTES, or QTES, you may call it in short, and I'll be happy to deliver you our R&D activities. First of all, some information about my university, which was established in 1973. There are 17 faculties and 27 research centers with more than 45,000 graduate and undergraduate students, 1,900 academic staff, 55,000 acres of campus. You can see it over here. It's really located at a very nice location. Dr. Erwan was here for the conference we organized. We are over a lake to the north of Adana in the southern part of Turkey. We have a regional hospital for 2,000 beds and 1,200 hectares of research farm. And where I'm from is shown in this red dot, Faculty of Arts and Sciences, Chemistry Department. I'm a professor there doing my research through Chemistry Department. I'm also the director of Center for Environmental Research of my university. So our R&D group on thermal energy storage, we started in 1986, I can say, and currently we have 2 professors, 1 assistant professor and 1 postdoc, 5 PhD students and 2 master's students. So far we have completed 12 PhD and 11 master theses on thermal energy storage, and completed international projects funded by EU, NATO, COST, or NSF or ARSS of Slovenia, and some national projects from all kinds of national funding agencies, including TÜBİTAK, Turkish Scientific Research Council. And the topics we are dealing with are listed in different categories here, and I will mention each of them with you as much as our time allows. First, we did some thermal energy storage potential studies, underground thermal energy storage material development, system integration, and information dissemination. The first master thesis on thermal energy storage was mine in 1986. This may be the first master thesis in Turkey as well on thermal energy storage. It was about heat storage in packed bed. As you can see, the flow diagram here, that was much before what the diagrams that you can draw with the software. So this was done by hand. And to this day, the packed bed storage is still being used and important, especially in high temperature storage, which we came back to. I will show you later on in one of our recent PhD theses. Then in 1992, I had my PhD again at Cukurova. It was on thermal analysis of heat storage materials and integrated heat pump and thermal energy storage system, which is shown over here. And that, I believe, was the very first attempt to combine thermal energy storage with heat pump operation. And here we used paraffin as phase change material in the heat storage. Later on in 1995, after I finished my PhD, I joined Cukurova University Chemistry Department. And in the very first conference that I have attended, the Kellerstock conference in Finland, it was on energy storage. I have met a group working on underground thermal energy storage, and they had a workshop there, and they asked me to join the workshop if I am interested. There wasn't anyone from Turkey. And I was invited to this IEA, International Energy Agency Energy Storage Technology Collaboration Program, through this workshop participation. And following that, our country signed the implementing agreement for this technology collaboration program in June 1995. And Cukurova University was assigned as a contracting party. And since then, I've served as a Turkish delegate in this committee's executive committee, had the honor of to chair the executive committee for 2 sessions, and also was the operating agent for Annex 14, cooling in all climates with thermal energy storage. Annex here is meant as a collaborative project between the member countries of the International Energy Agency Energy Storage Program. And right now there are 18 countries in this implementing agreement. So with 1995 was a milestone in our research, because we were able to join a large network where we can share and learn and transfer knowledge. And one of the first things we did, which was an Annex 8 project, was to work on an underground thermal energy storage potential project, which was done with a geographic information system to analyze the energy situation, climate conditions, groundwater, geology, agriculture production, industrial areas, etc., to map together and show the highest potential areas for different underground thermal energy storage projects. So this is an example of a map that we have provided with this potential study. Later on, with another project with Slovenia, University of Ljubljana, we did a potential study for solar energy utilization and thermal energy storage possibilities, and that was done in 2010 to show similarities between our countries and how important it is to use solar energy and importance of thermal energy storage in this utilization. We had different technologies of thermal energy storage in our research portfolio. One of the first is underground thermal energy storage. This was again another International Energy Agency collaboration project, which we did for our hospital at the university. It's about heating and cooling of our hospital with the lake nearby. You have seen in the opening picture as a cold source and solar energy as a hot source, using the underground wells shown here to heat and cool of our hospital. And we calculated the annual savings of 3,250 megawatt hours of electricity and 1,000 cubic meters of fuel, which would decrease carbon dioxide emissions by 2,100 tons per year, and the other related emissions also. So this was a feasibility study, and that was received well by the university administration, but was never established because it was thought to be very risky at that time, because there were no projects like that in Turkey, and the administration was reluctant to go on with it. It's a pity, but it was. Another storage, thermal energy storage for underground, was for borehole thermal energy storage, where we tried to determine the potential of winter air as a cold source. Adana, if you know the map of Turkey, we are in the south on the Mediterranean coast. It's a quite warm country, but this map on the bottom, graph on the bottom, shows that we have some hours which are very cold, below 10 degrees. So we tried to capture that cold hours and store it in the underground with a borehole thermal energy storage configuration shown here. And on the right-hand side, you see the temperature of the underground going down with the depth. Near the surface, you see that the temperature is around 21 degrees, but as you go down, after 10 meters, the temperature dropped to 14 degrees. We were able to decrease the ground temperature by 5 degrees with cold injection. That means we could use that cold for summer to cool down our buildings. This was a project done with Luleå Technical University in Sweden. It was a joint PhD study. Another joint program with Luleå Technical University was to use this thermal response test for borehole thermal energy systems. This was delivered to our university, and up till now we are using it for measuring thermal resistance and thermal conductivity of borehole systems around Turkey. And this map shows where the location of the measurements have been. These are for commercial projects. The next ATES project is for a greenhouse system. This time we have realized this project. It was for a 360 square meter greenhouse located on our campus that grows tomatoes and eggplants, tomatoes on the left, and eggplants on the right, shown here. And we were able to deliver the first ATES project in Mediterranean with 2 wells, and the distance between the wells 100 meters with a flow rate of groundwater 1.2 liters per second. We were able to decrease the energy by 68% to grow the products with 40% increase in yield, 0 fossil fuel consumption, except for circulation pumps and the fans that are run here. And this showed that ATES can also be used in Mediterranean region for the first time. I would like to now talk a little bit on our material development research, because we have a lot going on there, and we have done some in the past. Another milestone in our work is micro encapsulation of phase change materials, which we have realized with cocoa oil. You see in the middle, on the right-hand side, the cocoa oil is liquid at room temperature around 23, 24. But when you encapsulate it, it becomes a powder. And in 2004, this was not very common. I know there is now lots of studies on microencapsulation of PCMs. But when we got this capsules, I remember my PhD student screaming. He said, "We got this!" You know, it was really a very important point for us. And after that, we did a lot of microencapsulation. You'll see in the next slides. But in 2009, we also joined another project which brought us into another network that was a cost action project, where we looked at the next generation phase change methods for building applications with 23 countries. And we did some work also on salt hydrates, where we looked into decreasing the supercooling effect. And here you see a polyacrylamide gel composite we produced, and how we have decreased this supercooling about 3 to 4 degrees, a master thesis project. A joint project with industry near Adana that is the main producer of dimethyl terephthalate, DMT, which is used for PET bottles. We looked at the potential of using this as a high temperature storage material at 147 degrees. That was also a first for our study and also for the literature. Then we started looking at nanomaterials and PCMs. The reason we did that with the organic PCMs, you probably know, or maybe it's new to you, the thermal conductivity is very low. So there are a number of methods to increase the thermal conductivity. Here we use nanomaterials named in magnetit, iron oxide and zinc oxide. And then after synthesis, we added these to organic materials to determine how they affect the thermal behavior. And we used a special stabilization technique with oleic acid so that nanomaterial is dispersed homogeneously in paraffin. And this was a master thesis project, which later on our now Dr. Nurten Şahan went to Paris S.Pd University to continue our measurements with this nanomagnetic and paraffins. Here we saw that we can increase the thermal conductivity of paraffin by 50 to 70%, depending on how much nanomagnetic we add. But one point we did not expect was the latent heat of paraffin was increased by about 10% when nanomagnetic was added. This, we thought, oh, this is the error, because with DSC you can get this 10% difference, which is the differential scanning calorimeter measurement shown in the first graph upstairs. But when we repeated this many times, I don't know how many times we did, but we still got this 10% increase. And that was also a first we introduced into the literature. And the reason for this is still discussed about the nano interactions that may have caused this. We also work with PCMs, phase change materials, for cold storage applications by different groups of materials. Paraffin mixtures on the top, you see the paraffin heating and cooling mixture cooling diagrams that are very smooth phase change, and also aqueous salt solutions for lower freezing melting temperatures shown in the bottom graphic. And this was a project with Arçelik, a very famous white goods producer in Turkey, and they also produce internationally. We continued our microencapsulation for building applications. I have shown you the very first we did with cocoa oil. Here we work with different shell materials, with different methods of microencapsulation shown here. And we produced more than 50 different microencapsulated PCMs for the specific project we did with industry. I will show you later on, where we produced microencapsulated PCM for test buildings for passive solar energy storage. The latest test material we work with is waste material. For circular economy, using waste materials are very important. It's becoming more and more important. The picture that you can see on the screen now is from a demolition site. Recently in Turkey, we have lots of urban projects, urban development projects, where you have lots of demolished materials, and that is a big burden for the municipalities and the government. So we started with that and got some samples from the sites in Adana and did some processing and received these spherical sensible thermal energy storage materials, where we turned them into a packed bed shown here. And this packed bed includes a sensible thermal energy storage material to store heat up to around 200 degrees Celsius for especially industrial applications. and the density, specific heat capacity shown here are comparable and better than many other sensible heat thermal energy storage materials. And it's really very, very cheap to use, and you are polarizing a very bad waste material. This has been patented by our Ph.D. student, Burcu Kocak, which had a very nice thesis co-supervised with the University of Barcelona in Spain. Then we have some system integration projects, mostly with together with industry. This one is for domestic appliances, where we developed a PCM and then a thermal energy storage material. This is the upside down view of a dishwasher. So in this dishwasher, the blue box you see here is where the PCM is located. The idea behind this project was to use the waste heat from the first washing cycle and store it in this test module and provide it for the second washing waters preheating, and a joint project again with Arçelik funded by TÜV. Using PCMs with building materials, the first one we did was with İzocam, an insulation company in Turkey, where we added Micronaut, a commercial microencapsulated PCM, as a layer together with the insulation material, Isopan from İzocam, and tested it in a cabin to measure the heating and cooling loads. And we were able to reduce heating load by 23% and cooling load by 7%. The cold storage PCMs, low temperature PCMs that I have shown you previously, was used in refrigerators shown here, another project with Arçelik, and that's also a milestone project for us because this is converted to a prototype which is almost now in the market. And there you can see where the PCMs are located on the evaporator coils, which optimize on-off durations of the compressors and longer operation at optimum temperature levels when power is cut off. And here you can see some prototype test results, which shows a 9.4% energy savings, and compressor off time was increased from 39 minutes to decreased from 39 minutes to 133 minutes. And when you look at this, how this would how this impact Turkey in terms of energy conservation, we calculated about 500 gigawatt hours per year when all the refrigerators are equipped with PCMs of this kind. Another different application is using PCM together with root zone temperature control, where you have soilless agriculture in greenhouses, where hydroponic or in pots like this. We developed some PCMs that were used around these pots to determine the root zone temperature control, especially in the transition periods when heating is not used in greenhouses in November and March. And we could see that 1.9 to 2.4 degrees Celsius differences could be maintained around the root zone, which may help the plants to grow healthily. Another PCM project is for thermal management of lithium-ion batteries for hybrid electric vehicles. Here we tested the batteries. You can see at the top how we produce the battery module and the battery pack for 32 volt 10 battery module in series. We produced PCMs that could flexibly cover the battery pack. And without PCM, we saw that at ambient temperatures of 40-45 degrees, you can easily reach critical temperatures of 50 degrees or more. For lithium-ion batteries, this is very important because if you go above critical temperatures, you can have some thermal runaways, even some explosions and fires. With PCM and the graph at the bottom, you can see that the material we have used was paraffin with the nanocomposite that I have shown you before. We were able to get about 9.7 degree to 5.3 degrees differences between the condition without the PCM, depending on the ambient temperature, which made the battery work below the critical conditions. Microencapsulated PCMs in concrete for a passive building was tested together with Cambeton, another industrial company which produces prefabricated panels for buildings. Here I have shown you the microencapsulation materials we have produced, and we used them in two different cabins. Sorry, one cabin was a reference one, and two others with microencapsulated PCM and also without microencapsulation, and did some environmental and economic assessments. And a thermal camera image that I want to show from this passive building or composite wall. On the left-hand side, you see the composite concrete panels surface without microencapsulate, with microencapsulated PCM. In the first 6 centimeters, it's only concrete. In the second 6 centimeters, it's concrete plus microencapsulated PCM. On the right-hand side, it's only the concrete panel. So if we look at the thermal image, at 12:30 noon, the outside temperature is around, very hot, 35 degrees. With the concrete and PCM, the first layer, 6 centimeters, the concrete passes the heat almost without any absorption. So when it comes to the layer with MPCM, microencapsulated PCM, the PCM absorbs the heat. So heat is delivered with a delay to the inside, and inside temperature is kept around 23 degrees. And if you look at the thermal image on the right-hand side, you can see that the outside temperature is again around 35 degrees, but inside temperature is now around 27 to 28 degrees, which means that heat is delivered without being absorbed, a little absorbed by concrete, but not as much as it is with PCM. So that's the idea behind the passive use of microencapsulated PCM in concrete structures. A recent project we did was for citrus tree frost protection, which is a problem in our region, Cukurova region. We have lots of citrus orchards, but the temperature can get below zero sometimes of the year and causes frost, as you can see in this picture at the top, a tree affected by citrus. So we produced a thermal protection device shown here, and that orange figure here shows that. And we provided a thermal protection between -2 and -4 degrees for 7 hours. And on the right-hand side bottom, you see the PCMs that we have produced that were put inside this thermal protection device, which was patented as a result of a massive thesis project. The thermal energy storage for high temperature, remember the demolition waste materials that we have produced were used as a packed bed prototype, as I have shown you. We did some simulation studies on how to integrate these in industry, and this one shows you the potato crisp frying process and what will be the effect of using packed bed storage together with a solar field, parabolic field in this case, and we calculated that we can gain more from the solar field, about 5 gigawatt hours per year, and that would mean that 1.6 gigawatt hours per year comes from thermal energy storage, which leads to 40% fossil fuel conservation. And this was also part of the PhD thesis co-supervised with University of Barcelona. Another recent project we did with one of our PhD students, that was his interest in this 3D printer materials. He produced this 3D printer box, which he filled with a microencapsulated PCM that was produced in our laboratory based on lauric acid, but with a shell material of calcium carbonate, and filled this box with that and used it in a laptop underneath this area shown with this geometry. Figures being the input area, RAM area, and output area, and showed that the RAM area temperature could be lowered with this small 3D printed device and PCM in it. For information dissemination, we have done many things over the years. This is another milestone for us. 2005, we organized a NATO Advanced Study Institute on Thermal Energy Storage for Sustainable Energy Consumption. You see some of the students here. 68 students from 18 countries joined us and 22 lecturers from 99 countries. And many of the students shown here are now lecturers or experts working in this field. I'm happy to see that. We joined an EU Horizon 2020 project in PATH-TEST. It was called PhD on Innovation Pathways for Tests. And you see the institutes that were in this program, 2015. It was finished in 2018, and now we have an impact test network still going on, and the PhD platform for getting PhD courses. If you're interested, we can share that information later on. We organized the 14th International Conference on Energy Storage at our university in 2018. Dr. Erwan with us at that time.
Yes.
Yes, you can see this picture. Are you in this picture, Erwan?
Yes,
sure.
Professor.
Oh, good. Okay. So a little bit on the current R&D project, if I have time. The first one is biomimicry for PCM development. We wanted to look into the nature and learn from nature, and warm-blooded species, especially whales, that want to keep their body temperature constant at around 37 degrees through a blubber tissue they have. You see it enlarged here. And we mimic the composition of the blubber and try to get a new PCM, as shown in this green figure here, and then use some hydrogel composition to get the PCM at the bottom type. So it's kind of a blubber-inspired PCM, and now we are working on applications with that. We also looked at multifunctional microencapsulated PCMs recently, and here you see an example with silver nitrate forming a silver layer around calcium carbonate layer. which ended in increasing thermal conductivity of heptadecane, which is a paraffin, about 10 times. And especially when you use calcium carbonate, that helps that. On the right-hand side, you see the same image of the calcium carbonate, the shell, that's the shell material, and also the X diagrams which shows the composition of the materials that's on the surface, including silver and calcium. And another project we are doing with our Ph.D. students is was co-supervised with Professor Mohammed Farid. I also supervisor of Dr. Erwan, I believe, is on fluidized bed and using it with thermal energy storage. And we here have a small experimental setup where we use the micronal PCM to test the fluidization behavior and how much energy we can store through this. And we very happily to see that we can store energy very quickly, like in 8 minutes, and deliver at a higher temperature to the users. We are doing Erasmus Plus project with a number of countries from China, Malaysia, Thailand, and European partners, Italy and UK. The purpose is to enhance engineering skills of students for application in sustainable renewable energy solutions in built environments especially. And this is going on since 2019 and will end in 2022. We have a bilateral project with UK, Northumbria University on integrated renewable thermal energy storage system for reducing heating, cooling, energy burden in refugee camps. As you know, refugee camps are located at different locations in Turkey. We have many refugees coming from southeast and east of Turkey. And we want to help them with a renewable heating and cooling system with this project. We recently started a CSP AeroNet project. CSP is concentrated solar power plants, and this AeroNet is specifically on thermal energy storage options. And here we are participating with a packed bed storage for very high temperatures, in this case 700 degrees Celsius or above. And here we are collaborating with Spain, Israel, and Turkey. 2 industrial companies from Spain, one from Spain, one from Turkey are included. Finally, I would like to thank my research team. I have listed their names here. From the very beginning, I started my PhD and master's studies, and until now with all the students and postdocs and professors I work with, and also our industrial partners and funding and support received from many supporting organizations. And thank you all for listening to me. This is our university's web address, and this is the view from our faculty, actually. My room is not looking at this view, but you can go out and
nice.
I see, yes. And the bottom is our web group, CHUTES group website, which we are organizing right now. You can have a look. Thank you very much. I'll be happy to answer any questions you may have.
Okay, thank you, Professor Halime Paksoy. Thank you. Cute Karuna's presentation. Okay, let's continue to the next agenda. This is about the collaboration opportunity from engineering faculty that will be representative by Mr. Erwan Saputro, Ph.D. Please, time is yours, Mr. Erwan.
Good afternoon, everyone. It's good morning in Turkey and good afternoon in Indonesia. Yes, no, I start my presentation. Okay, Assalamualaikum warahmatullahi wabarakatuh. Hope the information from Professor Halime have good insight for us. And now we time to do the collaboration. So this is the implementation of Freedom of Learning and Freedom Campus, MBKM, UPN, Veteran Jawa Timur. So Professor Halime, at this session, I want to discuss about the possibility of collaboration between University of Cukurova and UPN Veteran Jawa Timur. In here, based on our legal foundation of MBKM, before I begin, I want to let you know that our government, starting last year, announced about the freedom of learning, freedom campus, that we can study outside from our university. So the legal foundation of the MBKM, of freedom of learning, regulation of the Ministry of Education and Culture, 2020, and there is decree of the Rector University of Pembangunan Nasional, Jawa Timur, for the implementation of freedom of learning. The objective of the freedom of learning is to provide the student right to study 3 semesters outside its study program in order to improve the competence of graduates, both soft skill and hard skill, which relevant to the future demand. To generate graduates as future leaders who have personalities and state defense characters as value of life, which relevant with university vision. The state defense is the main character of our university. To develop a partnership between university and government, university and private sector for implementing education, research, and community service. So this is the freedom of learning that our government announced. There's 8 scheme. The first one is student exchange with the other university in our country or in outside our country, internship that we go to the company or industry, humanitarian project for social program, entrepreneur, independent project, and thematic field work. So from this one, we need a partnership. This is why we invite you, Professor Halime, to have your insight here, and we may discuss about collaboration. The partnership activities that we want to gain with the Cukurova University, the first one is the student exchange. Up to second year student, 2 to 20 credit that we can apply, and credit transfer and or earning credit. For student year 3 or 4, we have a research funding and research collaboration. So it will take 4 to 6 months for the student to do the research outside our university. So we may send our student to go to Turkey for 4 to 6 months to do research. And then this program will credit transfer. So they earn the credit as well. And the supervised by both institutions. And the outcome is publication. Is for it. And then the last is independent project. So for years, student year 3 or 4, same 4 to 6 months, we have credit transfer as well, supervised by both institution, but the difference is the outcome. The outcome is product or blueprint or the competition for the independent project. So if this project in Turkey that we can collaborate or we can send our student to go there for 4 to 6 months, and there's good opportunity as well. Now I want to explain about our research. So our research also on thermal energy storage. A metal coated of basing matter that I already done with our team research and Microtech 24D. So this to continue and to about your research in Turkey and pasting material, and here we try to develop the metal coated one. Oh, why we do metal coated for the microcapsule? To make it stronger when applying a high pressure system. There are two steps of metal coated: surface functionalization using polydopamine and electrolysis plating using sulfur nitrate. This is our research results. This is the magnificent for 400 time, 1,600 time, and 6,000 time. This uncoated one, and there's the other one is the coated one. The coated one have the sulfur nitrate covered them, and that make them stronger. So when they apply in the high pressure one, does not make a dimple like this one. It's seamless. The future research plan is to identify the natural potential for fishing material and the coating process with cheaper material, because we do with sulfur nitrate, which is around 600 US dollar. It soon be highly priced for ours in here. So this is our future research plan that we may match with your research plan in your team in Turkey. And then this from our university. So the future plan following this event for collaboration is further discussion between President, Dean, or Chair of UPN, Veteran Jawa Timur, and Cukurova University, determine and offer the selected subject, course, research topic, and the program, arrange the quota, inbound student, researcher, or lecturer. This means inbound the university Cukurova can send the student to our university for credit transfer or student exchange. And then for outbound student, it's from University of Pembangunan Nasional to go to the Cukurova University. And the number four, prepare the selection criteria of participant, student, researcher, and lecturer. Before we begin to send student there, we have to what is it? Make a competition or selection first. And then the last is organize the schedule. So PIC and guideline activities. This from our university for the following this event. And thank you. This is from me. Thank you very much. And I give back to the moderator.
Okay, thank you. Thank you, Mr. Erwan Adi Saputro, Ph.D., for the presentation about the overview of the research
Mr. Miss Aini. Postpone, okay. Prof. Halime.
Yes.
Yeah, I'm waiting your offer about postdoc or PhD student in this event, because there's some my friend here, new lecturer, want to do the PhD in Turkey. So maybe you have an offer to them you can explain here. This is good opportunity.
Okay. Shall we wait for Dr. Fauziyah to join again, or shall I start?
Okay, we wait for a moment. Miss Tiara.
Yes, sir.
Yeah. So how we do it? We waiting for
Yes, please wait for
moderator.
a moment. There's
Oh, okay.
some technical issues here.
Okay. While we waiting for Dr. Nur Aini, we can discuss with Professor Halime. Professor Halime, how is Turkey at the moment?
We're doing okay. I mean, in terms of the pandemic, if you're asking,
Yes.
this new derivatives are not going so well. So we have seen increase of cases, but vaccination is underway. So we have been able to vaccinate quite a number of the population, and we are trying to have at least 3 vaccinations right now for everybody.
So it is okay to go to Turkey at the moment?
I think it's okay. I mean, there are some rules for some countries. I'm not aware of what rules are for your country, but we right now at the university we are teaching face to face. There is also the option of to teach online for some courses, and also in the schools for high schools and elementary schools, there face-to-face education started. So we're trying to get back to normal in all fields, especially in education. That's a major thing. In other than that, we can discuss the exchange possibilities if you like to do so now or maybe later.
Okay. I got the information from the committee that the moderator have problem with signal.
Okay.
So I may.
Now is.
Oh, no, it's okay.
Now is repair.
Okay, that's good.
Yes, it's okay. Okay. I'm so sorry, Professor, because of this mistake. Okay, this connection is not stable, so. Okay, thank you for the overview of Professor Halim and also Mr. Erwan Adi Saputro, Ph.D. So maybe we have any collaboration opportunity between the Cukurova University and also from UPN. Okay, for the next agenda, we continue to the question and answer. From the chat box, maybe all participants can join in if you have any question, or maybe if you would like to ask directly to Professor Halim, you can join and raise your hand. Okay, there is a question from Yelvia. Thank you very much, Prof. Halim. This topic is very interesting for me about the energy storage as one of the renewable energy. I have many questions to ask. What do you think about the solar thermal power plants? And then one of the solar energy storage can be true with PCMS, right? Could this PCMF method can be an effective energy save? And could the solar energy be stored as a latent heat for direct steam generation? And how do you think about the technique to improve and to optimize the PCMS? Thank you, Professor Halime. Maybe you can give your
Yes.
answer.
Thank you very much. For CSP, the solar power plants, they're usually
Yes.
from concentrated solar dishes and so on. So there you have a steam production at around 500 degrees or so, and the new generation CSP plants, they want to go even higher to 700 degrees, and that's the CSP Aranet project we're doing. And when you look at the industrial or power plant applications, thermal energy storage sizes you're talking about are huge. Okay, first of all, the thermal energy storage material that you are going to use should be cost effective. If you're looking at PCMs as they're available on the market today, you may find some very high temperature PCMs, not too many, and not very thermally stable maybe, but the problem is they are very expensive. Right now, CSP plants use molten salts and not as PCM. They use it as sensible thermal energy storage. They are very cost effective and used in many CSP plants, but they have some issues. Number one is corrosion and how to have a stable and long life operation. So the common trend is to go back to sensible thermal energy storage for high temperature industrial applications, for steam reforming, for example, or for CSP plants. And there are also trends in using phase change materials together with sensible heat storage to make them more decrease the volume of the storage, first of all, and also to provide constant temperature heat to the end user, because with sensible heat storage, you have a change in temperature during storage and also recovery. With PCM addition to the storage tank in different formats, you may get a more stable operation. There are also multiple PCM usage in cascaded, they are called cascaded thermal energy storage applications, but these are all still under R&D, research and development phase, and needs more work to do.
Okay, Professor. And the second question, this is about what is the effect of the using nanomaterials and micron-sized materials, maybe in the BCMS performance? Maybe you can tell us about this.
Yes, this is very interesting, as I have mentioned in my presentation. First of all, when you add a nanomaterial to a phase change material, how you add it is important, because you need to have the material dispersed homogeneously, and you want to be sure that it doesn't settle down after the phase change when it freezes and melts several times. And apart from that, the heat transfer mechanism of nanomaterials with PCM is something that's very interesting. We have some viscosity effects of the nanomaterials, and that may lead to some new interactions that causes a change in the latent heat. So that is our explanation of the 10% latent heat increase with iron oxide nanomaterials. But you may have, depending on what your nanomaterial is, different interactions with the PCM that you're using. So you have to consider that at the molecular level or even below that.
Okay, so the interaction is different between the nano and the micron size materials. Okay, this is very interesting. And then there is a question again. I have tried to prepare PCMS by using the PEG or polyethylene glycol and SeO2 for the PCMS. And then but when I try to characterize the thermal properties was have the potential as storage materials. But here I would like to ask, can you give us what step that we can do to make our materials more applicable as a PCMS? Maybe Professor Halime?
If I understood the question very well, PEG has a very different melting point varieties. I don't know which melting point you're looking at. It's a polymer, you know. Depending on the mass index, it has different melting points. For cooling applications, I know there are PEG studies that show the potential. Especially warm climates like ours and yours, I believe we have a challenging cooling demand that has to be answered, and phase change materials is one way to do it. And I think PEG is a promising material for that.
Okay. Thank you, Professor Halime. Maybe from the participant, have you any question again? Okay, there is one question more, Professor Halime, because this is very interesting, maybe. I think this is interesting for us. Okay, one participant asked about what is the size when we try to applicable the PCMS in the building? Maybe the size of the PCMS when we applied in the building. Maybe you can tell us.
I think you're referring to the microencapsulated PCM which we added to the composite concrete material. There we had nano size, like 200 to 400 nanometer diameter particles. And I haven't mentioned that, but the microencapsulated PCM, when you add to concrete mixes, which has, you know, some aggregates, which could have some frictions and so on, you can break the microcapsules, and that would cause the inside PCM to leak out from the porous concrete structure, which you don't want, and that's why you microencapsulate actually. But when you have a shell structure that is durable, and also the size of the microcapsule is very effective on that. We did a lot of tests on mechanical strength and also some morphological studies on how microencapsulated PCM behaves in the concrete structure, and so that when you decrease the size of the microencapsulated PCM and how you add it to your mortar during preparation, can affect a successful incorporation of MPCM to the concrete structure. I hope this helps. I don't know if there is more question about it.
Okay. Yes. Okay, thank you, Prof. Halim. Maybe any question again from the participant? Okay. Time is up, so maybe if you have any question. Oh, okay, please. One question again, okay? Oh, no. This is just about the, what is the PCMS if we try to, what is the material? This is very applicable in the PCMS. Maybe what characteristic materials that can we develop to be the PCMS? The last question.
Characteristic materials that can be developed as PCM. That's the question, right?
Yes.
Well,
okay,
you know, any material changes phase if you have enough energy for that. But the thing is, you need to have a material that changes phase at the temperature that you want for your application. Or if it's, for example, building application, then you want to keep a thermal comfort inside the building, then you want a material that melts at around 23 degrees or so. So if you look at the materials that are available, they could be paraffins, fatty acids, or inorganic materials like calcium chloride hexavalate, for example. But they all have issues that you have to work with and make them suitable for thermal energy storage. Or if you look at very low temperatures, I have shown the studies we made, you can have alkane mixtures or salt aqueous solutions as PCM that have minus 25 degrees, for example, salt solution you can get or more. So it depends on your application. So you know what your application wants, and then look at the materials that are available and see if you need to change anything in their properties or enhance them and how you can do that. But don't forget, when you're trying to adjust the properties and you add materials to your mixtures, then you are decreasing the storage capacities usually. And that would mean reduced storage capacity, more volume sometimes, and more cost because you add new materials and you need more material for PCM.
Okay, thank you, Professor. Maybe if any challenge about if any student would like to continue the PhD in the Cukurova, maybe from the other laboratory, can it join? Not from chemical engineering, maybe like that?
For universities to have international students in Turkey, we have to have Higher Education Council recognition of the university as international university. So the first attempt would be to have a bilateral agreement, for example, and to have that bilateral agreement, the Higher Education Council should recognize UPN veteran as the international university that we can work with. But if we want to work with the research on the PhD level, we don't need that. And then you would need some funding agency, either in Turkey or international funding agency, that supports the research project or a research visit. It could be an exchange program. And then if the laboratories in our university, mine are open to your students, PhD students, if they're interested, through these projects that are formed, they can come and spend some time. It depends on what your interest is. But what Dr. Erwan has mentioned, the 3 semesters outside your program, I think that's a very good thing that you're doing. To be able to do that, to have some undergraduate students, I think we need to have a bilateral agreement through our Higher Education Council recognition. And that, as Dr. Erwan again suggested, to have the deans come together and discuss the possibility maybe is a good way to do that in the future. I will take these to our dean and discuss with them possibilities. I already talked with the international office of our university and asked for the possibilities, and the first thing they said, we have to have the Higher Education Council recognition. And we also have a program called Mevlana. It is something like an Erasmus program, which is open to only European countries. Mevlana program is open to all the countries. The funding they provide is very small, actually, but it's an opportunity for students and also faculties to be exchanged. So I think that's something we can look at too, but we can discuss that later on.
Yes. Thank you, Professor. Please give applause for Professor Halime Paksoy for your time and your nice presentation for me. This is new insight for us to develop the research and do collaboration more with Cukurova University. Okay, finally come to the end of this international guest lecture. Before I close this session, I would like to take some conclusion from this webinar. First, in some project like greenhouse, and then refrigerator, and then batteries and other. And also, some method also can be developed, like micro encapsulation, and also the material also was varied. This is from coconut oil and then demolition waste and other. Okay, and the next for the collaboration opportunity, maybe we can do the collaboration in action by using the lecture or student mobility between the UPN and also for Cukurova University. And maybe all of the participants would like to continue the study in Cukurova University if this is open. Okay, thank you for the time and your presentation. I'm so sorry if I have any mistakes when I moderate this meeting because of the connection and other mistakes. I'm so sorry very much. Thank you, everyone. Thank you, Professor. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon. I will back to M.Si. Bye. Thank you.
Thank you.
Okay, what an excellent presentation from our keynote speaker, Professor Halime Paksoy. Such a new insight for all of us. To all the attendances, we would like to remind you to fill the attendances list, and the link is in the chat room. Ladies and gentlemen, now that we are at the end of this insightful agenda, we will hold a photo session. To keynote speakers, the dean, moderator, as well as participants are welcome to take a position for a photo session. Please kindly open your camera. Okay, 1, 2, 3. Again, 1, 2, 3. Thank you.
Excellencies, distinguished guest participants, ladies and gentlemen, now we will close this international guest lecture. We would like to thank the keynote speakers, the dean, to moderator, as well as all the participants in this international guest lecture. Let us all be guided by all the things we have learned and heard throughout this international guest lecture and be able to see and influence our future. Till we meet again in the next international guest lecture, may all of you have an excellent journey ahead. Wassalamualaikum
Assalamualaikum
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Thank you, Professor Halime. Sorry.